Good morning. We are here live today for episode 2 of Coffee and Compressed Air. Last week, if you missed it, we covered pressure drops and how to identify and find them so you can address those issues. And today I am here with Martin Zeller from CS Instruments. Make sure to check out and follow his page for more information there. And today we will be covering, you want to start monitoring your compressed air system. So what are the steps in order to accomplish that? And I will let you take over.
Good morning, Danny. Thank you very much. Thanks for having me here. So we get often approached by engineers asking, so I want to measure and how do we start? So we like a strategical approach to this. Of course, you can always try to do this ad hoc, pick something up. But if you start from scratch, there is a strategical mapping process, which we like to follow, at least give the guideline with it. And I want to share that approach with you today. So typically we start at the point of generation. Imagining you don't have anything, you start with pressure monitoring. Directly after the compressor, you make sure that your baseline is right. That's pretty straightforward, very simple. And yes, most of the customers do have that in place today. The next step is of our 9 steps, which we have in total. The next step is making sure that the dew point is right after the dryer. This is already a step which is not always taken care of. We hear many customers and users saying, yeah, I have a dew point sensor in my dryer. But is this enough? We unfortunately often see it that this is not enough. In refrigerant dryers, first of all, you don't necessarily have a dew point sensor in it integrated at all. You just have a thermocoupler. So that's not real dew point, not real pressure dew point. So what we advise is put at least 1 dew point sensor before you go into the main header directly from the compressor room where the dryer is. Making sure if you have multiple dryers, at least you capture that point when the dryer doesn't work anymore and you can stop the process before your line gets too much water. Or ideally, we prefer that a lot. Put 1 dew point sensor after each dryer so you know exactly immediately which dryer is affected in case it doesn't work. So there are multiple dew point sensors available, multiple different functionalities, and we can certainly help you with that. The next step of our mapping process is understand your demand. Understand what the compressor is discharging. This means in the compressor room, put at least 1 wet airflow sensor directly behind the compressor, and ideally after the dryer as well, so if the dryer runs efficiently and that the compressor discharges what it says it does, and understanding your demand profile. So this is the initial step of measuring compressed air is the 3 steps: pressure monitoring, making sure that the dew point quality is right, and then understanding the demand profile with differential pressure, wet airflow sensor, and the thermal mass directly after the dryer, ideally. So with this, you can then identify validating the cycle times, making sure that the compressor capacity is right versus factory demand. So that's really what you want to understand. And for the dew point, you want to understand that you adhere to the ISO standards or to the dew point you need to achieve with dryer, right? The next step is making sure if you have already a seasoned plant, and most of us don't have a brand new plant available, right? You should do leak detection survey. You should start working on your leaks. This will increase your bottom line right away. It's a very common, in an oil plant, it's very common that you find leakage rate of up to 30% of your energy consumption, right? Fixing 10% can have a massive impact on first of all, your productivity, but also on your energy bill, which improves the bottom line right away. So this is something you really should do. Go to the leaks, detect them, and fix them. So it's not a rare occasion where we see leak detection is done, but are they really fixed? This needs to be a clear goal. Manufacturers across the globe call it a treasure hunt, going for a treasure hunt, because there are such significant savings to be made. So we really encourage plants to do a leak study either by themselves or hiring a qualified professional who can do this for them. The next step after that, once you have done the actual leak survey, is mapping the distribution. Where does your compressed air go? making sure that you understand where is the highest demand of your plant. It's never even, right? So you have high profile users, high profile machines which require a lot of flow, and some departments that require less flow. Once you start mapping this, put a flow meter or put multiple flow meters in that line, put it towards high users, and make sure you map the header. You understand, ideally with a bidirectional flow meter, if you have receiver tanks laid out in the plant, the demand profile changes. You have flow going both directions. And with a bidirectional flow meter will enable you to do this, to read this, and understanding the entire demand profile. If you have limited budget, start gradually. Go to the high consumers first. Go into the header, understand where the air goes, and move from there. Once you have done this, the next step would be making sure that you understand the power profile, the actual consumption of energy of the compressor room, right? Of the compressor in the compressor room. If you have multiple, you have to do this. Obviously, you should do this in multiple. So making sure that you understand the efficiency metrics. This is done with kW meters. It could be done with an amp meter. It's better than nothing with an amp meter, because then you don't really measure the voltage profile of it. But if you have the ability, get a specific power meter which measures both voltage and amps and can calculate automatically all those power metrics like specific power, and you understand. Sometimes the reality is hard, right? Once you measure, you will see if your compressor runs efficiently. And once you know that specific power metric, you can work on it. You can work on your system. And again, you will find big savings. Very likely you will find big savings. So these are the first 6 steps of our mapping process. There are another 3, but you really should start from the bottom up. If you start from scratch, right? So this is the ideal case, that you do it gradually and with a systematic approach. You shouldn't worry about air quality if you haven't your basis right. So it's easier, work on the basis first, making sure that you got this right. Once you have the basis right, then you go to the actual higher profile monitoring, which I touch now. High profile monitoring, air quality in accordance to ISO 8573-1, meaning, for example, residual oil content monitoring. Residual oil content monitoring, this is really one of the more sophisticated systems. You need to have proper filtration in place. You cannot just go into a oil spitting monster. You cannot just put our sensor in. You will destroy it, right? So you need to make sure that you have the filtration in place. But companies who have to be in class 1 or class 2 or class 0, if they don't have filtration in place, they will never achieve that, right? So it starts with proper compressor, proper pipes, not infested pipes with already historic oil in it, and making sure that this is right. And you need to we really urge our customers on new prospects, if they are interested in this, that they really make sure that they monitor. If you don't monitor it, you'll never know what you actually do to your system and to your end products. Sometimes it's an end product air challenge which you may have. You may face some recalls. For instance, a water manufacturer, like bottled water, they can't have a little drop of oil because it will contaminate the entire batch. This would mean recalls, costly recalls. It would mean cleaning up your pipes. It means so many high dollar issues which you may face. It's really worth going and investing into this oil vapor device and making sure that the dew point is right. That's the same thing. It just goes also within ISO particulates. If you have your oil in line, we typically see, if you have your oil in check, typically have the particulates in check as well, because the filters sort of capture that. But this is really the most important, having your oil in line and dew point.
So can I interrupt very quickly? Because you shared an interesting story earlier. This facility thought they had everything set up, good to go, that they were oil-free, so that they didn't have to think about it.
Right.
Do you know what I'm talking about? Can you share a little more on that? Because they thought they were good. And it was very interesting, like one of those random cases that you don't think of.
Right.
But if someone's dealing with this.
So we had this one case where a customer said, "We're all good. We are class 1, but why don't you put the oil sensor in? We want to see how this performs." So we ran it over a period of time, and once you measure, you start knowing. I mentioned that earlier. So We saw that it was in line for a while, and all of a sudden we got this sudden spike in our oil reading, and nobody had any idea where this came from. And it turned out, after some investigation was done, they mapped it always happened at the same time. It didn't come suddenly and it was gone, and it didn't come ever. It came always at the same time. And they noticed that it had to do with shift changes. So the minute they had the shift ended, they had the compressor towards the parking lot, so the intake air came from the outside, and it was just facing the parking lot. So they sucked in that contaminated air, and it infected their readings. They were all of a sudden no longer in class 1, they moved towards class 2, and then it dropped again. For them, it was a big deal. It may not for somebody else, but for them, it was a big deal. We can't be in class 2, we need to be class 1, because they need to prove it. They have certain regulations, quality department would be all over them, and so on and so forth. So they had to fix this. They had to make sure that this no longer happens. And luckily, they were able to find this. There are tons of cases like that out there. Often we can't talk about it, but this one was a good one to share. And then going back to my initial mapping approach, after that, we go from residual oil, making sure that the air quality is right. We would advise to go to point of use flow metering. So point of use, this is where then you use the volume. Point of use can be, for instance, a laser cutting machine. It could be a large stamping machine, which requires a lot of air, but also can go to some customers really exercise this almost to the last machine, because they do departmental billing. They really want to understand where is the compressed air used. And some companies go that far and they start not only billing the department, but actually bill the end user who buys that product. So they actually start billing that into their price, factoring that in, right? So this is the extreme. I wish we would see this more often, but honestly we don't. But it's really identifying, understanding where your need is, making sure that you have your high end users, high profile users under control. Getting alarms. Sometimes an alarm is important. If the flow drops, you want to get an alarm. Hey, before you produce too much garbage, rather stop and wait until it comes back up. Sometimes you have those. And the last step after the multi-point flow measurement is making sure that you measure also multiple spots. The pressure. Pressure is not always the same. We think and we wanna dream that the pressure is always stable once you measure it in the front at the compressor room at generation. Unfortunately, it's not. You have pressure drops in the system. You have all of a sudden a massive leak somewhere, and the multi-spot pressure measurement will enable you to see those critical locations where you have a pressure drop. We need to investigate what's going on. So this is the typical set of 9 steps, how we like to map it. Yes, we know reality is you have a historic system, you have sometimes a sensor here, a sensor there, but this is a good guideline to see where can you start with monitoring. Sometimes we need a quick fix somewhere where dryer failed, we need to now do it. We know that we don't have it there. This happens all, we understand that, and we're happy to help you. But coming in with this strategic roadmap of how do I plan and lay out my measurement, how do I plan my measurement strategy, this really helps. And customers are typically very grateful to use this as a guideline. I hope you find this insightful too.
It's good to know just where things are, because compressed air is so important to so many processes. And I like that, because when I came here, my idea was that sensors are mainly for energy savings. I think that's just what most people would associate it with. And most of our conversations have been about processes and quality, which was a little surprising to me. But that's also what's most important to some of these manufacturers, because if they ruin batches, have recalls, especially in food or pharmaceutical, but even aerospace and car manufacturers, they have very, very strict rules.
And they have those they need to monitor their energy consumption, but they have processes within the plant which has the strictest quality monitoring as well. Paint booths. Well, you must have proper adhesion for paint in order to work right and not have expensive recalls. Imagine you have to fix a lacquer peels off or a sunroof because the adhesion doesn't stick anymore. Imagine this, because you had a little bit of oil in and the adhesion doesn't stick of that sun, and more is glued today. It's bonding, right? So you don't use the rivets that much anymore. If you don't have proper adhesion, you have a problem, right? So managing dew point, managing oil, making sure that you don't have particles. We all know what happens if you have sawdust all over and you don't make this clean and you just put some glue over it afterwards. It doesn't stick. It's the very same thing what happens in a car production. If they have some contaminants, this adhesion bead doesn't stick. And then you have costly recalls, expose your users to fatalities. Potentially, imagine they drive with 80 miles an hour on a highway, sunroof comes off. Things like that happen, right? It's not, and you don't want to have that. So making sure that your air quality is right is critical. And those beads are applied with air guns, with the spray, the paint is sprayed. The beads are pressed out, the thick glue is pressed out with an air gun. You need to have that under control.
Perfect. So that's bringing us right to about our 20-minute mark, which we love to stay at for everybody because it's a very quick break because everybody has to get back to work. I don't think I have any questions now, but you guys can feel free to reach out. You can DM myself or Martin for any questions. Or is there a good email that anybody can ask questions?
Yeah, of course. You can use info-us at cs-instruments.com, or just private message me on LinkedIn. We are available, or just go to our website. You find all our details in there. Just give us a call.
Perfect. Well, thank you, Martin.
Thank you very much.
Thank you, everybody.
Thanks for having us.
Enjoy your day.
Bye.